Hi friends, welcome to the channel JAIIB and CAIIB Made Simple. So this is our AVM theory unit number 7, completely in English. The chapter name is estimation. So in this chapter we are going to discuss first introduction. We will see the objective, estimates, estimator and estimates, point estimates, interval estimates. These are the two kind of estimate that we have: interval estimates and confidence interval, and finally interval estimates of the mean from large sample. So these are the 7 topics which we have to go through, and also 8 topic is interval estimate of the proportion from large sample. So let's start with the basic that is our introduction. So have you ever crossed a busy street? Tell me, have you ever crossed a busy street? Obviously you have. Without even thinking, you estimate the speed of cars, the distance, and whether you can make it safely or not. That is estimation in action. But did you know the same skill is used in banking and finance every single day? Let's break it down in a way that is simple, logical, and CAIIB exam ready. Let's understand everyday estimation. How do we do everyday estimation? You know that from crossing road to shopping budget, right? We make estimation all the time, but in the financial world, estimation are more than just guess. They help professionals make critical decision. For example, a credit manager decide whether to give a loan based on an applicant past payment behavior. For example, a prospective home buyer, right, estimate property price before purchasing. For example, bank predict interest rate trend to set policies. So just like we estimate daily, bankers use data driven estimation to avoid risk and make informed choice. So what is the big deal about population parameter? Let's understand this population parameter, very important. Imagine you are polling a city opinion on a new policy. So suppose some new policy is about and you are polling, right? You are polling on the city opinion. Okay, you can't ask everyone, so you take a sample, maybe 1,000 people, right? Obviously there are more than crore people in a city, and suppose there are lakhs in people in city, you can't ask them everyone, so you take 1,000 people at the sample, right? And use their response to predict the views of the entire city, right? Use their response to predict the view of the entire city. That is what happened in exit poll, right? So in banking it is the same. Financial analysts don't have access to data on every single loan applicant or all businesses, right? So what they do, instead they use sample data to estimate broader trend. They use something called sample data. The bankers use something called sample data to estimate the broader trends, and this process is called inferential statistics. The process which we are discussing right now is what we call inferential statistics, where we make prediction about a large group based on a smaller sample. You must know what is the meaning of inferential statistics. We have a small sample, right, and based on this small sample decision, right, we are making prediction about a large group based on this small sample decision. So this is called inferential statistics. There are two key concepts in inferential statistics. The first is called estimation. What are the two key concepts? Let's go through. There are two key areas of inferential statistics. The first is called estimation. You know what is the meaning of estimation? See, estimation means using sample data like a survey to predict things. So you using sample data like a survey to predict things like future enrollment. Okay, future enrollment in a bank training program, likelihood of a borrower repaying a loan. So you are using sample data to predict these things. That is called estimation, right? What is the future enrollment in a bank training program? You predict it. What could be the future enrollment, and you also predict the likelihood of a borrower repaying a loan. And there is second thing which is called hypothesis testing, which means this help banker and analyst check if a claim is true or not, such as will reducing interest rate actually increase home loan. These tools help financial professionals make better data driven decision instead of relying on intuition alone. So these are the key areas of two key concepts in inferential statistics. First thing is estimation, using sample data to predict things, that is called estimation. And second thing is hypothesis testing, which means help banker and analyst check if the claim is true or not, like will reducing interest rate actually increase home loan. This is called hypothesis testing. So these tools help financial professional make better data driven decision, right? So instead of relying intuition. Now the question is, how do we get it right? How do we get it right? What is the practical application? So bank don't just estimate randomly, rather they use precise method. right? They use, so these are the uses which I just talked now. So bank don't just use randomly, they don't just estimate randomly, they use some precise method to estimate the population proportion, to estimate the population and mean, that is the average credit score. For example, I am giving example, for example, average credit score of loan applicant, right? You can say average credit score of a loan applicant, right? And also minimize error. Two things, two methodology. Bank don't just estimate randomly, they use precise method too. Why they use precise method? To estimate population proportion and mean, that is the average credit score of a loan applicant, and to minimize the error in estimation by using a statistical control. So there is something, a term called a statistical control, right? So this method, this statistical control is used to minimize error in estimation. So these control ensure that data are accurate, data are reliable, and also data are based on, it is based on solid data, right? So at the end of the day, whether it is predicting loan approval, future investment, or economic trend, estimation plays a huge role in finance, right? So and as a CIIB aspirant, understanding this concept will not only help you crack the exam but also make you better decision maker in your banking career, right? So friends, let's talk about the types of estimate. So imagine you are predicting a cricket score. You confidently say, I bet the team will score 350 run, right? You say, I bet the team will score 350 run, right? But what if they score 340 or 360 instead? Were you completely wrong, or were you close enough? This is exactly how banker and financial analyst estimate figure, sometimes with a single number and other times with a range, right? In this slide, we will break down what point estimate means and what interval estimate means in a super simple way, right? So two way to make estimation. In finance, we often estimate unknown parameter. Based on available data. So there are two way to do this. The first way is called point estimate, right? So point estimate is a single number estimate, and second method is called interval estimate. Interval estimate, you know, this is a range of possible value. So whenever I say interval estimate, it means range of values, and whenever I say point estimate, it means a single number estimate. Let's break them down. So first of all, let's talk about this so-called point estimate. You know, point estimate is like making a confident guess with exact one number. You are using a single number. To make a confident guess, right? For example, a college dean says, sorry friends, a college dean says next year 350 students will enroll in this course, right? You predict that that a cricket team will exactly score 350 run. So sounds good, right? But what if you are off by just 10? What if you are off by just 10? Not a big deal. But what if you are off by 90? That is a problem. The problem with point estimate is that point estimate does not tell us how wrong we might be. So while it gives a quick prediction, it lacks accuracy, it lacks confidence, right? That is the benefit as well as the disadvantage of this point estimation, because you know it is useful when accompanied with an by estimates of potential error. It should be useful if it is accompanied, right? If it is accompanied by estimate of potential error, then it is most useful. What if your estimate is off by only 10 students? Obviously this is a good estimate, but if off by 90 students, it becomes unacceptable. So point estimate does not tell us how wrong we might be. It does not tell us how wrong we might be, right? So while it gives a good quick prediction, it lacks accuracy, it lacks confidence. So that is the drawback of this point estimate, right? Quick estimation is the pros. Now let's talk about the second types of estimate that we have, and it is called interval estimate. Yes, interval estimate is more realistic because it provides a range instead of a single number. So here the key point is range. It provides us a range. For example, instead of saying 350 students will enroll, the dean says that enrollment will be between 330 to 350. Yes, so this is called interval estimate. The dean says that enrollment in this course in next year will be 330 and 380, right? Example number 2. Instead of guessing 350 run, you predict the team will score between 340 and 360, right? You say that the team will score between 340 to 360, right? So why is this better? Because it account for error. It account for error in the estimate. That is why it is better. Second point is that it gives a probability. It gives a probability that the actual value will fall in this range, right? And the third thing is that it helps in decision making. Sorry friends. So these are the three advantages. It helps in decision making. So there are three advantages of having interval estimate. First thing is that it accounts for error. Second thing is that it gives a probability. Third thing is that it helps in decision making. For example, if a university expect 330 to 380 students, it can plan for 4 to 5 section, right? So for example, if a university expect 330 to 380 students, so it can plan for 4 to 5 section instead of committing to the exact number. So in banking, interval estimate help predict loan approval, market trend, investment risk more accurately. So conclusion is that while making estimate, a point estimate is a quick and simple number. Faster, if you want fast result, point estimate is the good, because it is a quick and simple number. But an interval estimate is more practical and reliable. In banking, we always aim for accuracy and confidence in our estimate, which is why interval estimate are preferred. So I hope this concept is clear now. I hope this explanation makes sense to you. Right, now let's discuss the estimator and estimate. Very, very important thing. So friends, ever wondered how do we predict big financial figure using just a small set of data? So think of it like tasting a spoonful of biryani to judge the entire dish. The small portion, that is the sample, give us a fair idea of the whole, right? So that is the importance of sample. So this small portion is sample, it gives an idea of the whole, right? In banking world, we do something similar. We use a small sample to estimate a larger population behavior. You can see we use a small sample statistics to estimate a population parameter. I think you are familiar with this term statistics and parameter. We have covered it in the sampling chapter. This is where estimator and estimate comes into play. Let's break it down in the simplest way possible. The first question to answer is estimator and estimate. What is the difference? See, estimator, whenever I talk about estimator, it means a formula. It is just a formula, right? Or a method we use to estimate something unknown. And whenever I talk about estimate, it is the actual number. What it is? It is the actual number. It is the actual number we get from using estimator. So let me give you example. For example, a bank want to estimate the average loan amount borrowed by customer. The bank want to know average loan amount borrowed. Bank is interested to know what is the average loan amount borrowed by the customer. Okay. Now in this case, estimator will be what? In this case, estimator will be the formula we use. In this case, estimator will be the formula like the sample mean, like the X bar. This is the estimator. And what will be the estimate? Estimate will be the actual calculated value. Estimate will be actual value. Suppose we calculated 5 lakh. So this 5 lakh is the average estimate. This is the average loan amount borrowed. I hope this makes sense to you. Let us take another example. Let us take another example to make it more clear. So here example is given in your book. Let us take an example that suppose if we check 10 taxi, and find that average mileage is 98,000 mile. This is the average mileage. That is our estimate for the mileage of all taxi in the city. So estimate is the actual number and estimated is the formula which we use to calculate the estimate. I hope this makes sense. Now question is, what makes a good estimator, right? So let's answer this question. So now that we have understood the difference between estimator and estimate, right? So sample mean, right, it can estimate the population mean. So this is an estimator. So what is the next question to answer is that what makes a good estimator? This question is asked every year. So you must know the criteria for a good estimator. Not all estimators are really equal. A good estimator should meet 4 important conditions. First thing is that it should be unbiased, which means it should not lean too high or too low, right? It means it should not lean too high or too low. For example, if we estimate the average salary of bank employee, suppose we estimate what is the average salary of bank employee, the method should not always overestimate or underestimate the actual salary, right? So that is called unbiasedness. So if you want to calculate the average salary of bank employee, so the method which we use, it should not always overestimate or underestimate the actual salary. That is called unbiased. Second point is that it should be efficient. What it means? That it should have the least error. So when I talk about efficiency, it means it should have the least error, which means that it gets us close to the real value, right? For example, if two banks estimate customer saving, the one with least variation is the better estimate. So suppose two bank I am taking, bank 1 and bank 2, they are estimating the saving. So it says saving, so in the first case the saving is having more variation, and in the second case the saving is having the least variation. So the one having least variation should be preferred. That is called efficiency, means a smaller standard error. And whenever I say standard error, it just means variation. So variation should be less. The one having less variation is more preferred, is a kind of good estimator. First topic, it should be unbiased. Means what? If we estimate the average salary of bank employee, the method should not always overestimate or underestimate the actual salary. The third key parameter is called consistency. What it means? It means the bigger the sample, the more accurate the estimate. So sample size increase, accuracy increase. That is the meaning of consistency. Let me give you example. Checking the income of just 5 customer may not be reliable, but checking 500 customer give a better prediction, right? So larger sample size and increases, accuracy increases. That is called consistency. And the last is called sufficiency. Sufficiency, you know what is the meaning of sufficiency? It should use all available data. That is called sufficiency. All available data should be used. Nothing is wasted. For example, if we are estimating loan default rate, suppose we are estimating loan default rate, right? So we should consider all relevant detail. All details should be considered. What are the details? Like past payment history, credit score, employment status, instead of relying on just one factor. So you must remember this mnemonic SUCE. This is a trick to remember the 4 characteristics. S stand for sufficiency, U stand for unbiased, C stand for consistency, E stand for efficiency. So these are the 4 criteria. One time question was asked like this: which of the following is not a criteria for a good estimator? Some other option is written, right? So you should know it, right? So I just talked about all the 4. So conclusion is that in a banking and finance, estimator help us make prediction using a small data sample. A good estimator should be unbiased, efficient, consistent, and sufficient. So right, so every data you have to take into consideration. Consistency means larger sample size, more accurate the data is. Efficiency just means that it should have a smaller variation. And the first topic, unbiasedness, you know it very well, right? So for your CAIIB examination, just remember, estimator is the method like sample mean, and estimate is the actual number. Understanding this will help you in risk management, credit analysis, and financial forecasting. So I hope this makes sense to you. Now let's move to the next topic, that we have the point estimate. So now here start point estimate. So friends, imagine you own a medical supply company that ship thousands of syringes daily. So you own a medical supply company which supply thousands of syringes. Do you count each syringe in every cartoon before billing? Of course not. Instead, you take a sample, a small sample, calculate the average, and use that number for all the cartoon. Sound smart, right? That is exactly how point estimate work in statistics and banking. So the question is, what is this point estimate? You know, point estimate is a single number. Whenever I say point estimate, it just means a single number used to guess an unknown value for a large group. For example, the average number of syringe per cartoon. Let me give you one example to make it more clear. So for this medical supply company we are talking about, so for average number of syringe per cartoon, this is point, syringe per cartoon, right, in a medical company. So this is the point estimate. Also another example, we can say the average loan taken by bank customer, so this is another point estimate. Instead of checking every single case, we take a sample, calculate the average, and then use as the best estimate. So what we do, just let me summarize the fact. So what we do, we don't check every sample, we don't check every single case. Rather, we take a sample, we calculate the mean, and we use that as our base estimate. That is the point. So let me give you a real life example. Let's say a medical supply company need to bill customer, right, based on the number of syringe per cartoon. Cartoon, you know, syringes. So instead of opening and counting each cartoon, they take a sample of 35 cartoon, right? So 35 cartoon sample was taken. Okay. Now they count the number of syringe inside, and it was recorded like this, right? So in first cartoon 101, second cartoon 103, third cartoon, this is the number of syringes. So there are 35 cases, and what they do, they add all of them. So after adding all this value, what they get was 3570 number of syringes. Okay, now what they do, they divide by the sample size. What is the sample size? 35. 35, n is equal to 35 is the sample size. So they divided by 35, and after dividing they got something called sample mean. What was the sample mean? Sample mean was 102 syringe per cartoon. So instead of counting every single cartoon, they confidently use 102 as the estimated number for all cartoon, and this save time, this save effort, and this save the money, right? That is the point. So this point estimate of 102 syringe per cartoon is accepted for billing purpose. Now the next question is, why is sample mean a good estimator? Let's answer this question. So just now we have calculated the mean. So why is it mean a good estimator? Is it a good estimator, and if it is, why is it? Sample mean is the best estimator for true population mean, right? So just let me show you. Here it is written that sample mean, here it is, here you can see the sample mean is the best estimator of a population mean, because it follow 3 golden rule. The first golden rule is that it is unbiased, which means it neither overestimate nor underestimate. Second golden rule is consistency, which means the larger the sample, the more accurate it becomes. And the third reason is the efficiency, which means it has minimal error, making it highly reliable. And what was the fourth reason? Sufficiency. Sufficiency is not there because we are not taking all parameters into consideration. So because 3 golden rule are being followed, that is why sample mean is the best estimator. And thanks to the central limit theorem, right, you have heard about this in the sampling chapter. Thanks to this central limit theorem, when we take large enough sample, the distribution follow a normal distribution. You know it very well. When we take large enough sample, distribution follow a normal distribution, normal curve, making our estimate ever more precise. So what we learned from this discussion is that point estimate are super useful in banking, finance, business. Whether estimating customer spending, credit worthiness, or fraud risk, a small sample can give powerful insight. For CAIIB, just remember, point estimate means a single best guess using sample data. And you must remember that this sample mean is the best estimator for the population mean. Understanding this will help you master risk management, data analysis, and financial decision making. Now, let's move to the next topic. Next discussion we have. As you can see here, we are talking about estimating population variance. So friends, have you ever wondered how business estimate product defect or customer behavior without checking even single item? Imagine a company shipping thousands of cartoons daily. How do they know how many will be damaged? Or how do quality control team estimate the consistency of the product size? Consistency, we just talked about consistency, which means the larger the sample, the more efficient the error is, right? That's called consistency. So the answer lies in sampling and estimation. Let's break it down in the sample. While we are estimating the population variance, why n minus 1? Why not n? Let's understand it. So what is the meaning of this variance? So this variance tells us how spread out, it tells us how spread out the data is. So when estimating variance from a sample, we can't just divide by n, right? What is the n here? A small n is the sample size. We can't do that. We can't just divide by n, right? So doing so give us a bias result. If we do so, we will get something called bias result, right? So and it make our estimate more accurate. So what we do, instead we divide by n minus 1. We divide by n minus 1, right? So we divide by n minus 1, making our estimate more accurate. So let us correct our formula. You know how to calculate the variance. So variance is equal to s square, standard deviation square. So s square is equal to summation of x minus x bar ka square upon n. This is wrong formula. So what is the right formula? The right formula is here. Just let me show you. Yeah, this is the right formula. We divide it by n minus 1. So what we do, summation of x minus x bar ka square upon n minus 1. This is how we calculate the variance. So question is, why n minus 1? Think of this as a small correction that ensures that our sample does not underestimate the true variance in a population. It is a mathematical fix that improves the accuracy, right? Now let's calculate the point estimate of, let's discuss the point estimate of the population proportion. Very important. Let's say a company want to estimate how many cartoon gets damaged during shipping. They can't check every cartoon. So what they do, they take a sample, right? So let's say that the sample size is 50 cartoon. Let's understand it. So let's say they take 50 cartoon into consideration, and they see that 4 cartoon have been damaged. So the sample proportion formula is beta is equal to, or we write it p bar. Suppose I write beta is equal to damaged cartoon in the numerator upon total sample in the denominator. So what is the number of damaged cartoon? It is 4. And what is the total sample? 50. This will give us 0.08, or we write it 8%. So based on this small sample, they estimate that 8% of all cartoon in the entire shipment are likely to be damaged. Right? Based on this small sample, this is the estimation that we get, that 8% of all the cartoon in the entire shipment are likely to be damaged. So this help in making decision like improving packaging or handling procedure. Right? Now let me give you some real life example for calculating this population proportion. Let me give you. So here you can see some example have been given. So imagine you are a manufacturer measuring the diameter of a sphere. So you are measuring the diameter of a sphere, right? Instead of measuring every sphere, you take a small sample of 5. You calculate their diameter. One is 4.33 centimeter, 4.37, 4.36, 4.32, 4.37. Now what is the point estimate of the population mean? What you will do? You will add all of them. You will add all of them, divided by 5, and you will get 4.35. And what is the point estimate of the population variance? So how do you do? This is your mean, and you will apply the formula x minus x bar ka whole square upon n minus 1. N is 5, so divided by 4 under bracket. Right, under bracket 4.33 minus 4.35 ka square plus 4.37 minus 4.35 ka square. Similarly, you will add to all, you divide by 4 and take under root. This will give you variance, which is nothing but 0. You do this calculation yourself. You will get 0.00055. So this means without measuring every single sphere, we can estimate the average size and variation with confidence. So estimation technique are powerful tool in banking and finance and business, whether it is predicting loan default, estimating customer churn, or quality control in manufacturing. Sampling save times. So for the time being, you must remember that variance estimate use n-1 to remain unbiased, and sample proportion help estimate population proportion, right? And estimate guide decision making in the real life. These 3 things you must understand. I hope you have mastered the concept of point estimate. So now let's move into the world of interval estimate. Very, very important. So friends, imagine you are buying a car battery. Let's take one example to understand it. Imagine you are buying a car battery, right? So the manufacturer claim that it lasts 36 months, right? But will every battery last exactly that long? Probably not. Some might last 34 months, some other 38 months, isn't it? So how do we estimate the average lifespan of all battery? Instead of guessing, we use something called interval estimate, right? So we use something called interval estimate, which is a powerful tool in statistics. Let's break it down. So I already told you the difference between point estimate and interval estimate. Point estimate gives you a single number, right? Like saying the average battery is 36 months. And interval estimate gives you a range, like saying that average value lies in the range 35.3 and 36.7. Now tell me, which one sound more realistic? Obviously the interval, because it acknowledge uncertainty and give a better picture of the population, right? So here you can see what we have done. We have collected a sample, a survey was conducted, and we have collected 200 battery users. We calculate the sample mean and got 36 months. We calculate the standard deviation and we got 10 months. Okay, this is given to you. And we calculate the sample size is 200 because we have taken 200 battery. Now, the first step to do is to calculate the standard error. Super important thing. Try to understand. What we will do, we will calculate the standard error of the mean. How to go about calculating it? The formula you know it very well. We have already covered in the sampling chapter. Sigma x bar is equal to sigma upon root n. What is sigma here? Sigma here is the population standard deviation, which is 10. And what is root n? Root n is 200. So after calculation, you will get 0.707 month. So you can see it here. Let me show you. Yeah, here it is 0.707 month. So this means the actual battery life may fluctuate slightly, but we can estimate the true average with a confidence range. So what does this mean? So instead of saying that battery will last exactly 36 months, what we say? We say that the average battery life is 36 minus 0.707 and 36 plus 0.707. If you write it, it is equal to 35.3 and 36.7 month. Why is this important? Because it helps business, customer and financial analysts make better decision. So what we learned from here, that point estimate gives single value, interval estimate gives a realistic range. Standard error help measure uncertainty in estimation. So you know why we calculated the standard error? Because this help calculate the uncertainty in estimation, and this will be a powerful tool which we will be using throughout this chapter. right? And interval estimate improve accuracy in the decision making. Now let's see this particular graph. Already I told you, using central limit theorem, we can assume that our distribution will be normal. That is what you can see, normal distribution drawn here. So friends, now let's understand what this graph is telling. You see this bell-shaped curve? This is called normal distribution. The curve represent the distribution of sample mean if we repeatedly took sample of 200 battery. So this is the distribution of sample mean. You can see distribution of mean of sample. Not sample, mean of sample. How mean are distributed, right? That it shows. Due to central limit theorem, even if individual battery lifespan vary, the sample mean will follow a normal distribution. Now, mean is how much? 36 months. You can see this is mean is represented. The dashed vertical line at 36 months shows that average battery life based on the sample. You see this dash line, dash black line, this shows the average battery life. If we take multiple sample of 200 battery, their mean would be close to this value. Now, sample size is how much? N is equal to 200. So, a large sample size reduces variability. If n increases, our variability decrease. Why? Because sigma x is equal to sigma upon root n. Obviously, n increase, sigma x bar decrease. That is why variability decrease. So, with 200 battery, and this will make our estimate more accurate. If we increase the number of sample, our estimation will be more accurate. So with 200 battery, the sampling distribution is expected to be narrower, meaning our estimate has less uncertainty. So this graph shows that even if individual battery life vary, the average remains stable, and large sample leads to more reliable estimation. And this is the application of central limit theorem, right? Now let's calculate the probability of population parameter within a certain interval estimate. So friends, before that, let me show you. Okay, so we will understand it. We will draw the graph later also. So understanding normal probability distribution allows us to relate a specific proportion of the area under the curve to probability. By applying this property, so here is the key point, that area under the curve to probability. By applying this property to the standard error of mean, we can estimate the range where the population parameter likely fall. So let's discuss the key points here. So first of all, you see this particular graph. This graph, you will understand everything. Let me zoom it a little bit, right? Let us understand this particular graph here. What does this graph represent? So this graph visually represents confidence interval around different sample mean, and so how often they contain the true population mean. And what is the true population mean? True population mean is mu, right? And mu you can see. So let me zoom little bit, zoom out. I hope this is now visible to you quite clearly. Now you see the bell shape curve. This curve is a bell shape. This is called bell shape curve. You understand this bell shape curve? I hope you do. Right. So this blue curve, you see this blue curve represents the distribution of possible sample mean. And the center mu, you see this center is mu. The center is mu. It represents the true population mean. And the spread depends on the standard error, which is our sigma x bar, which is a measure of variability in the sample mean. Now, let's talk about confidence interval and probability. Very, very important point. Let's talk about confidence interval and probability. So there is a rule which we called 95.5% rule. What it say? If we take multiple sample and construct interval around their mean, which means plus minus 2 error, plus minus 2 standard error. If we take multiple sample and construct interval around their mean, 95.5% of this interval will include the true mean, which is represented by this. You see this 95. This you can see 95.5. So 95.5% of the. So let me give you an example to make it more clear. So suppose you take 1000 sample. So it says that if you take 1000 sample, around 955 interval will correctly include mu, right? So if you take multiple sample and construct interval around their mean, right? So 95.5% of this interval will include the true mean. So if you take 1000 sample, so about 955 sample will correctly include mu. In this diagram, Moss interval capture the true mean except one, which is our x4. This x4 is outside it. You see this? x2 is inside, x3 is inside, x5 is inside, x1 is inside. So 95.5% of it inside this particular area, this area, which is denoted by blue color, blue curve. and 1% which is one case which is outside, it does not capture it. So now question is, why does this one interval, this is an interval, you see this interval, I hope you can visualize this interval, let me show you. You see this is interval. So why does this interval miss the mean? Because since confidence interval are not perfect, 4.5% of them may not include mu. That is the trade-off of estimation. The interval, if you see the interval around x4, the interval around x4 is an example of one that misses the true mean. So this is the first rule. This is called 95.5% rule. I hope this makes sense. There is another rule which is called 68.3% rule. What it says? It says that if we use plus minus 1 standard error, right? It says that if we use plus minus 1 standard error, our interval will contain the mean 68.3% of the time. Right? So while doing 95.5% rule, we were using plus minus 2 standard error. And if we use plus minus 1 standard error, our sample, right? It says that if we use plus minus 1 standard error, our interval will contain the mean 68.3% of the time. So what we learned from this particular graph, right? We learned from this part, you see this minus plus minus 2 minus x, that is what the point. So we learned that confidence interval are crucial in finance and risk management. They help estimate a range where the true population value like average return, risk or loan default is likely to fall. So this is the range, they help estimate the range. Not all interval will capture the true mean, but most will. And this helps us make data driven decision with a quantifiable level of certainty. Yes, we say that 95.5% of the time it lies in this range, and that is what is represented in this particular diagram. And there is a 68.3% rule also, which is for plus minus 1 standard error, and 95.5 for plus minus 2 standard error, right? This is the point. Now let's discuss understanding the confidence level interval in the simple terms. Let's understand it with using an example. So have you ever wondered how company predict how long a product like a car battery will last? What if I told you we can estimate it with a confidence without checking every single battery in existence? Sound interesting, right? So we are diving into confidence interval, one of the most powerful statistical tool used in banking, risk management and finance. And trust me, once you understand it, you are one step closer to acing your ABM examination. So the first thing we have to understand is that this is called best estimate, right? Best estimate. So best estimate, but it is not perfect. Why? Let's discuss. Imagine you are the director of a battery company. You are a director of a battery company, right? You want to know the average life of your car battery. You want to know that what is the average life of your car battery, right? But testing all the batteries is impossible. Can you test all the batteries? Is it possible? Let me know. No, it is impossible. So what do you do now? So what you do, you take a sample. Let's say we surveyed 200 battery, right? Let's say you surveyed 200 battery, okay, battery users, and found that average battery life is 36 months. But here is the catch. This is just a best guess based on the sample, and there is always some error possible. So instead of giving just one number, we give a range, a confidence interval where the true battery life most likely fell. Now let's talk about this confidence interval. The first section we have just discussed what? We have just discussed the best estimate, but it is not perfect. I say that yes, this is the 36 month is the sample estimate, that 36 months is the average life of the battery, but is it correct? No. Then the best estimate is what? The best estimate is the confidence interval. What do they mean? Let's break it down. Based on our sample, we calculate different confidence interval. Like you can see, 68.3% confidence interval. The battery life is between, in this case the battery life is between 35.293 and 36.707 month. This is month, which means 36 plus minus 1 times sigma x. Okay, 36 is our mean, right? And 95.5 we take 2 standard error. So life is between 34.586 and 37.414. And 99.7% confidence level, life is between, we take 3 times sigma x, 33.879 and 38.121. So what do this number mean? The higher the confidence level, you see, as we moving the down, our confidence level is increasing, isn't it? Confidence level is increasing. The higher the confidence level, right, the wider the range. You see this range wider, the range is becoming wider. Earlier the range was only this much. Okay, just wait a minute. So as our confidence level is increasing, our range is also getting wider. Can't you see it? I hope you can easily see it. Just wait a minute. So you can see it easily. Initially our range is only this much, now our range has become this much, and now our range has become this much. So as confidence level increases, our range is also increases, right? The wider the range. And if we want to be 99.7% sure, we give a bigger interval. And if we are okay with 68.3% certainty, the range is smaller. So depending on how much confident we are, right? Now it is all about balancing accuracy and precision. You know accuracy and you know precision, right? Accuracy, suppose I draw, I hope you know it very well, right? There is two things we have to balance: accuracy and precision. So suppose this is our target, this is our target, and we hit 5 times, and we always hit the center, we always hit the center, right? So this is called accuracy. But we hit like this, one time here, one time here, one time here. So this is called precision, precise. So we are balancing accuracy with precision. Now you might be thinking, right? Now you might be thinking that why don't we just use one confidence level, right? Why don't we just use one confidence level? Great question. In real life, different situations require different confidence level, right? Like you can see 90% confidence, right? So 90% confidence means plus minus 1.64. You see this curve. So 90% confidence means plus minus 1.64 standard error. So right. So use when we want a reasonable estimate. This is used when we want a reasonable estimate. And 99% confidence here plus minus 2.58 standard error is which is used. It is commonly 99% is used when precision is critical, when we want to be precise, right? And there is something called 95% confidence level, which is most common used in business and research. So most commonly we use 95% confidence level, but sometimes 90% confidence level is also used when you want a reasonable estimate, and 99% use when you want precise. So the next time you hear a prediction, check the confidence level. A statement like we are 99% sure hold a very different weight than we are 90% sure, right? So I hope this is now clear. So why this matter for CAIIB? So confidence level, confidence interval are everywhere in finance. When bank estimate risk, interest rate or investment return, they don't just throw out number, they use confidence interval to measure uncertainty. So remember, no estimate is 100% perfect, but with confidence interval we can make informed decision based on probability and data. So I hope this make you concept clear, right? So this is all for our part 1 lecture. We will cover the rest part in our next lecture. So do stay tuned for the next part. Thank you.